Like we have done about the atomic structure, we have done about the binding energy concept. These all are, like, as far as exams point of view, binding energy and the calculations based on that, they are important areas. Then we have concepts of stability of the nucleus on account of the binding energy per nucleon. Then we have nuclear forces and characteristics of nuclear forces. Further, we have under characteristics of nuclear forces. Last week's class, those who have seen, you might have seen simulation as well as video based on that. Today, the last part of the chapter, and even about nuclear fission, chain reaction, nuclear reactor, and the parts of nuclear reactor, how a nuclear reactor is used as in nuclear power plants. All these are the areas we had discussed last class. Today we will focus on radioactivity. Sometimes you might have studied some areas of radioactivity in chemistry. Let us see what all areas we have in physics to understand about radioactivity. So, very first thing is, what is radioactivity? What do you mean by radioactivity? Some nuclei, they are very, when they are unstable, they will keep on emitting radiations. Basically, that is radioactivity. But the instability, it's like just let us assume, like we people, we are you must have many friends having very different behavior when they are in anger. So, in an angry mode, you just assess yourself or ask yourself, what you will do when you are really angry to everyone. So, you will express your anger in different ways, right? Some have a very bad habit of throwing things here and there when you are very angry. This is what the situation of a nucleus. A nucleus, when unstable, what happens is it will throw the things away from whatever is inside the nucleus. Okay. So, what is the reason for the instability? When you what will be the reason for your anger? There are so many reasons. You were promised about something, but it was broken so many times. So, you are continuously the instability keeps on increasing, and one day you will burst out. This is what is happening with the nucleus. Nucleus, what happens is, the nucleus, when it becomes unstable, instability arises due to basically we can say the large difference between the proton number and neutron number. So, if there is large difference between proton number and neutron number, what happens is the instability of the nucleus arises. So, what happens when the nucleus is unstable? It will keep emitting radiations. It is a spontaneous process. Radioactivity. This phenomenon is what is called radioactivity. So, radioactivity is the phenomenon of spontaneous emission of radiations when the nucleus becomes unstable. What is the reason for instability? Once again, instability arises when there is a big difference between the number of protons and neutrons inside the nucleus. When you look at the lighter and lighter nuclei, like say for example, in helium 2, 4, like 2 protons, 2 neutrons, carbon 6 protons, 6 neutrons. So, like that in the normal isotopes of or normal elements of normal nuclei of elements, what happens is there will be almost equal number of protons and neutrons. But when you take the case of heavy nuclei such as say uranium 238, and its atomic number is only 92, that is 92 protons are present, whereas 146 neutrons, there is a big difference between the proton number and neutron number. This is what is making the nucleus unstable. So, the unstable nucleus, what does it do? It will keep emitting radiations. See, just imagine, think of like this example I always used to say in the class when I am teaching this content to my students. Like if there are many types of people, think it that way. Some have the suppose somebody is coming to your house, okay, as a guest, and inside the house you are unstable, you are with anger. Okay, you are throwing things here and there, that's what is happening, let us say. So, some people will think that, okay, this is not the right time for me to go there, get inside, so I will go back. And how about some other people? Some other people will need to know, we need to know what is happening inside. They will be more eager to see what is happening. And third category of people, what happens is they will when they come to the house, there may not be any issues. So after coming over there, they will say that okay, why you were see why it is like this, why you were promised many times, but it is not at materialized. If I was in your position, I would have done so many things. That way what will happen? The problems will be induced. That's the third category of people, right? Then you will become unstable. That means you will become you will be angry. So these three categories of people, you just think of this one. Why I mentioned this one is it is relevant here, because the first person, the first kind of guests, okay, the first person who came to the house, it's like they just observed that there is an instability. This is what is the role of the first scientist, Henri Becquerel. Okay, Henri Becquerel. So what's the role of Henri Becquerel? He observed that there is radioactivity, there is instability arising. Okay, this is done by Henri Becquerel, correct? Now, the second group of people, the second category of people means it is like they want to see what is happening inside. That is analyzing what is going on inside the nucleus, right? And that is why by another scientist named Rutherford. Okay, so what is the role of Rutherford? He analyzed and he found out that there are three kinds of radiations coming from the nucleus. Okay, he only found that there are what is a alpha particle, beta and gamma, alpha, beta, gamma, that is determined, that is discovered by Rutherford by an experiment. I will show you the experiment. And third name, what you should say is about Curie. Otherwise you might have heard of Curies. The what you call as the couple Marie Curie and Pierre Curie, Madame Curie and Pierre Curie. So these two scientists, what is their contribution? They in fact we can say in a way, many contributions they have. In a way we can say in this context, we can say they have made the artificial radioactivity, artificially inducing radioactivity. So the third category of people. Okay, so the Henri Becquerel found out. So you should know these three names clearly, because these names would be again useful later on in another stage as well. So first Henri Becquerel, what's the contribution? He found out there is instability in nucleus. Rutherford, he found out that there are three types of radiations coming from the nucleus. And third one, Curie, is about inducing artificial radioactivity. It has become a very big boon in the field of, especially in the field of medicine and also. For example, radioiodine. The normal, the disease goiter you must be familiar with. Goiter, swelling of thyroid glands. For the diagnosis of this disease, we use radiomedicine we use, that is radioiodine, that is radioactive iodine. It's a very useful tool for diagnosing the disease goiter. Alright, so this way it has opened to a wider field that way, the radiomedicines. Okay, it has come due to as a result of artificial radioactivity. So let us again start this way. What is radioactivity? So we have said a definition, just memorize the definition properly. That is, it is the spontaneous emission of radiations from a nucleus when the nucleus becomes unstable. So what is the meaning, otherwise what is the significance of the term spontaneous? Why you should use the term spontaneous? What does spontaneous mean? By the way, you must have seen on the screen, you can see the telephone number 052 9611 If you have any clarifications required, if you have any doubts to be cleared, you can very well call us. This is the right time. You can pick the phone and call if any confusions there, or if you want me to explain something to you. All right. So let's come back to this. What's the meaning of spontaneous? Spontaneous means it's like it is not induced by someone. Otherwise, it is not affected by, or it is not influenced by someone. Again, there also my students must be remembering, I have mentioned about the definition of poetry. Poetry. What's the definition of poetry? You might have studied in literature. What you studied is, it is the spontaneous. Why? When I was a student, I memorized this definition of poetry. It is a spontaneous overflow of powerful feelings recollecting triangulity. You might have heard of that definition, right? So there, what does spontaneous mean? As far as a poet is concerned, spontaneously, the ideas should come out spontaneously. There is no external influence. Nobody is compelling him to write a poem, right? It comes from himself, from inside. So that way, a nucleus, it emits radiations by itself. There is no if there is a change in the pressure or change in temperature, no external factors can influence the radiations, the process of radiation. Okay, that's the meaning of saying spontaneous emission of radiations from nucleus. So what is the definition of radioactivity? It is the spontaneous emission of radiations from a nucleus when the nucleus becomes unstable. Okay. Now let us see, when the nucleus is unstable, it gives out radiations. Initially it was assumed that there are it is giving out radiations only, like energy is coming out. But later on, the scientist named Rutherford only said the nucleus has got 3 types of radiations. He found out there are 3 types of radiation in a specific way. All right. So we will come back to that point after seeing a short video. The video shows what is actually radioactivity. Okay. So you just watch the video, and after the video we will again come back and discuss about Rutherford's contributions. First you watch this video.
It can change spontaneously from one element to another. The name for this process is radioactivity. You probably already know something about the nucleus. It's much tinier than the atom. It's made of particles called protons and neutrons. There are electrons orbiting around it. And though the atoms can share or swap electrons when they bond together, the nuclei themselves never change. Right? Well, no. Certain nuclei are not stable in that way. This means they may change suddenly, spontaneously. The radioactive nucleus flings out a small particle and transforms into another element, just like that. For example, a carbon nucleus can eject a fast-moving electron and turn into a nitrogen nucleus. There are 2 different particles that can be emitted from radioactive nuclei, though never together. The very fast electron is known as a beta particle. If you know a little bit about electrons, you may be thinking, what was the electron doing in the nucleus in the first place? The answer is that a neutron in the nucleus spontaneously changed into a proton, which stayed behind, and an electron flew out as a beta particle. This is not what chemistry has taught us to expect. The nucleus is supposed to be stable. Neutrons don't change into protons, except sometimes they do. The other particle that emits spontaneously from an unstable nucleus is alpha. An alpha particle is 8,000 times more massive than beta, and it's a bit slower. Alpha is made from 2 protons and 2 neutrons. If we trap a lot of alpha particles together, we get helium gas. Alpha is a helium nucleus. Like the beta particle, we would not have expected a heavier nucleus to throw out helium. But again, it happens, and the nucleus becomes a new element. So, is radioactivity useful or just dangerous? Wherever you are sitting, it is quite likely that there is a device nearby which contains a source of alpha particles, a smoke detector. The source is radioactive americium. You are totally safe from these alpha particles, which cannot travel more than a few centimeters in air. Beta particles penetrate much further through materials than alpha can. Radioactive atoms are used in medicine as tracers, to show where chemicals travel in the patient. Beta particles are emitted and have enough energy to emerge from the body and be detected. There is a 3rd type of nuclear radiation, gamma, which is not a particle at all. It is an electromagnetic wave, like microwaves or light, but it is actually 1,000 times more energetic than visible light. Gamma rays may pass right through your body. Gamma is used to zap the bacteria in fruit to increase its shelf life, or in radiotherapy to kill cancer cells. Radioactive substances get hot, and this heat can be used to generate power. This heat has been put to use in space probes and, in the past, in pacemakers for hearts. The more abruptly nuclear radiation is slowed down, the more damage it does to the atoms it hits. This is called ionization. alpha causes the most ionization as it crashes into other atoms, and gamma the least. For humans, the most serious effect of radiation is the damage that it can cause to our DNA. Although alpha cannot penetrate your skin, if you inhale or ingest a radioactive nucleus, the health consequences can be severe. Radioactivity is both useful and deadly, but it is all around us as a background to the natural world.
Yes, that's a video that is in fact depicting most of the things related to radioactivity. It says about the emission of alpha particle, beta particle and even gamma radiations. Remember, when you talk about alpha and beta, we mention the names, when mention them as particles, whereas for the other one it is gamma radiations, it is radiation because it is an electromagnetic wave. So, there clearly you should study the properties of alpha, beta and gamma radiations, and actually how the alpha, beta and gamma radiations are being detected by the scientist named Rutherford, that I will explain after a short break. We will come back after a short break. Okay, stay tuned.